we have Trapti Kalra joining us from Gurgaon, and she'll help us look into edge AI and delve deep into its trust enhancing aspect. So that's the panel on the enhancing solutions, trust enhancing solutions. Trapti Kalra is an artificial intelligence leader whose interest in the field of research and academics has led to expertise in the field of neurosciences and AI. Welcome, Trapti, and it's over to you.
Hi, everyone. Thanks for the welcome and thanks for giving me this opportunity to present some of the work we've been doing, which is very much related to what Boom does, right? It's fact checking. So today I'm going to kind of spend a lot of time in talking about solutions which help us in fact checking, verification, and how AI is helping us get there. So before that, I do want to, just take some time to share a presentation which will help us just navigate this space a little bit. If you can just confirm, Venkatesh, that my presentation is visible. Can I get a confirmation?
Hi. Trapti, hi. Can you see the
Yeah.
share button at the bottom of your screen? If you click on it, you should be able to share your presentation. It's not shared yet, but it'll come through. And while you're doing that, yes, I acknowledge what you said. There's a lot of work we do in parallel, in consonance. We focus on dealing with misinformation, and increasingly we have to tackle that question on a real-time basis of how AI tools are being used. So it looks like it's working. So it's back to you, Trapti.
Thank you so much. So using AI to develop solutions you can trust and developed on the edge. This technology is very accessible, and the agenda for today is that just an introduction to AI and edge AI in specifically, and what makes this technology possible. What is the tech stack, and uh, how does it really work? And what is the art of possible? In particular, what are the verifier solutions, the type of solutions on edge that we're going to be talking today? I'll also present some proof of technology, what the delivery approach typically is, what are the challenges and opportunities, and what is the future scope. So it kind of, really links well into the sessions we've had since the afternoon when Sailesh Kumar from Geo, he presented the framework, the fact that we need to think about scalable solutions, formulation based, and how edge and all other technologies enabling AI become very important. To the talk we just had on open source. So today we will also see how we are using open source extensively to make these solutions possible. Edge AI specifically is when AI automates some problem, some use case at the point of action. Exactly, you can take your solution right up to the point where you need to where some action is happening and you need AI to come and assist you or help you in taking decisions or measuring data. So there are some terms which we keep using. So one is the Internet of Things, which is essentially the ability of smart devices such as wearables, drones, robots, your smart speakers, the the AI enabled cars, etc. All these are smart devices. IoT is really the term when we enable these smart devices and edge compute to connect to the cloud, to the network from where they can receive data and send data. The cloud term which we use today is essentially hybrid cloud, where we are able to today have work seamlessly across multiple clouds as well as private clouds. And that along with the IoT capability makes it a very strong proposition. But it is not always that we need to send our data to cloud. Many of these smart devices of today require some kind of capability to execute a AI program on the device itself. Even collecting data as well as giving a prediction on that data is required, especially when we are caring a lot about privacy. So Edge computing is what we call the terminology when we enable our edge devices, which are somewhat, you know, limited in terms of the hardware, which is restricted, size, memory, etc. Yet the technology today is enabling us to execute some kind of AI on the device. So a lot of the solutions which we are working on also address this need for having your data not really going to the cloud but remaining private, and yet being able to run the world class technology on those devices. So the in order to make edge computing a possibility, we need to think about what are the dynamics, the market and technology dynamics that make this possible. So why do we have this technology in the first place? So today there is a big need for, compute which can run in low latency and give us give solve our problems in real time, so or near real time, and this could be in, really sensitive areas where we are looking for results immediately, also to maintain privacy, and also to have, very specialized use cases addressed in specific industries or in specific businesses. And then, because of the advent of mobile technology, almost everybody has a computer in their hand, and they're looking at solutions which can be practical and usable to the individual. So all of these are drivers for, the whole uh, AI ecosystem looking into edge computing and trying to leverage that in the context of AI. The other, at the same time, we have a lot of opportunities as well. So there is a lot of advancement in the edge AI processes. We'll be talking a little bit about what kind of capabilities we have. Again, open source frameworks. We just had a talk right now. Um, and the open source frameworks enables a lot of, you can say, uh, advancement in the technology by just, having your frameworks in open and the community improving them with the individual ideas and specializations, right? So this, along with the fact that technology is standardizing, whether you talk about wearables, robots, drones, edge, almost each smart device has a kind of standardization to which we are gravitating. And this democratization in technology enables us to use, to really scale up the solutions that we present. At the same time, there are some challenges, as with all new technology, which is just booming. The compute for real time on edge devices is limited. There are challenges around power consumption. So as long as it is 1 watt to 15 watt kind of a um, power requirement, it suffices. But beyond that, we may need to invest in heavier edge equipment. Size and memory constraints and hardware restrictions apply even today, but this is also, changing, and there is a lot of room for the edge hardware market to actually evolve, and they are evolving. So if you look at where we will be in the next 5 to 7 years, I think the whole market is really maturing, and you can see that with the kind of products that we have, some of the pictures which are presented on the left hand side. So, for example, this bot which you can see, this is actually a spot bot, which actually we work to develop a lot of edge solutions, which can do inspections in warehouses, manufacturing units, etc., by doing real time predictions for things like, whether there is some heating issue with equipment in a factory, or whether, there is some equipment which is faulty. So those kind of solutions are anyway today becoming more and more ubiquitous. And when we talk about edge solutions, there are some restraints. One is, we have limited uh, on-device training. So typically, the AI itself, the engineering will happen on a cloud, on a, bigger server, and then it will be compressed, or you can say, kind of optimized to run on a edge device. The other restraint is that it's very difficult to get data and samples for training in very specialized use cases. This is one of the challenge which I'll also talk about in our, verifier technology, how that works. And second thing is AI talent is of course an issue. The people who can really design these solutions, I'm not really talking about people who can write code or just do the engineering part. I'm talking about people who can think through the whole problems, the use cases, and how to solution that use cases, and that risk taking ability to bring the solutions to life. So that is also where there is a huge opportunity, and that will also be something I'll focus on the later part of the talk. So going forward, just to introduce you to why this technology is very, very accessible. So there are a lot of edge platforms and devices by some renowned companies like NVIDIA and Intel. At the same time, on the open source front, we have Linux and Android uh, supporting us with platforms. Now, these specific platforms, the way they work is they're specialized platforms for edge computing. At the same time, there are in the market edge devices, which have again been coming from both open source as well as from some of the companies. Our edge devices would typically be like NVIDIA has the Jetson Nano series kit for edge. Similarly, Intel has the Movidius neural compute stick. So these are some of the technologies. And when I say they're accessible, I mean, in India, we could easily get some of the devices which you can see pictures of in as much as less than 10,000 rupees. Yet they're very powerful. They're like a miniature computer with even with they can be equipped with all kind of sensors, as well as you can deploy a artificial neural network solution on this and run it in real time to get your results. And all this is possible because of the, again, optimization libraries that are supported. So we have TensorRT, which is again open source by NVIDIA. OpenWindow is Intel's platform. And TF Lite is another platform which is supported by TensorFlow, which is enabling us to put this technology on devices. So with this, the software stack which goes along with it is what is typically used by data scientists. You have Python, PyTorch, TensorFlow, all these technologies which are used very pervasive now. Python as a language, Linux as an open source OS. Most of the technology which we're going to be looking at today is all developed using these kind of frameworks, which are very, very accessible and again low cost. So one of the solutions which we're going to talk about a little bit more in detail is going to be on the mobile verifier technology. This technology enables us basically in the current state, it uses a lot of visual AI and computer vision applied in a very, very unique way with the help of hardware devices or equipment which can be attached to a phone, let's say an Android phone. Again, it's manufactured by certain companies going to be in the market soon. Once this is deployed, it can actually take images of a substance or any material. It could be like a liquid, and the equipment specialized for liquid is shown here, or it could be a solid. It could be a solid substance such as medicine pills, or it could be something like a bacteria, because this lens is microscopic. So all these substances can be imaged, and then using those images, we can train the AI models for a specific purpose, and that purpose could be to recognize the optical characteristics of that substance, whether it is related to color, motion, hue, saturation, etc. And using all of this, we model the material in a way that we are able to test whether any new sample which is shown to this model and it is imaged, does it belong to the same sample training set? Does it have the same characteristics? Is it very different? Is it, has the quality deteriorated than what quality benchmarks we had set across? And this powerful idea has given rise to a whole set of use cases in multiple industries, which can help both businesses as well as individuals. So we'll be taking a look about that. So, for example, in food manufacturing, you can think about, any kind of produce, like the quality of your pulses or the rice products, etc., which need to be sampled and attested for quality. You could have a device on your phone uh, and a software application and a mobile application, which is helping you identify you can say the quality of the rice or the name and details, and just the way the pulses are, whether they're a good quality or is it a bad quality, are they infected or are they not infected. And this could actually transform the capability for both a business which is involved in, let's say, packaging and labeling their produce, as well as an individual who's buying their produce. Similarly, in textile manufacturing, you may be aware that there's an entire system of how we grade textiles during manufacturing. Let's say cotton is produced from cotton balls, which are coming, and when you actually do the processing, there is different quality of the cotton which is getting produced. So it is measured by the color, the amount of impurities which are there present in the cotton, as well as the length which is coming out for the cotton, and the thickness. So all these attributes go into a extensive process which is manual today. And in India there is a lot of money and effort being spent on it, but this entire process could actually be automated by using this technology in a creative way to solve and do this automation for the entire pipeline. In life sciences, when we talk about our medicines and pills and the efficacy of a medicine, again, from observing some of the properties which could be related to the visual quality degradation in the, again, hue, saturation, color change, as well as the labels which are getting tampered. You could do, again, a lot of work to just maintain the authenticity of the product. Similarly, like counterfeit goods on its own, it's like uh, there's a research published which says it's a $50 billion plus problem. So this technology itself can be used, just the normal powerful cameras that we have, the high resolution cameras on the phone, they can also be used to detect counterfeit products. So right now we are doing experiment with a e-tailer on the shoe, counterfeit shoe identification, just based on the visual signature which we are getting from images. And that could be related to the texture, the kind of designs, the quality of the logo, how it is getting printed, the reflective index on the paint from the shoe, etc. So so in order to just tell you another big use of this is in forgery. So you can talk about artwork. So one of the work which we've done, which I'll just demonstrate, is on art, exactly being able to identify whether a painting is forged or not. A currency, similarly for gems. So before I take you any further, I'll just like to run a video. So maybe Abhishek, you'd like to just run the video for us, which demonstrates this technology. Thanks for playing that. So as we can see, the technology value behind this entire solution is, one is a lot of the use cases which I addressed today. Uh, there is also counterfeit detection, which is going as a parallel non-AI industry. But the problem with that is, number one, it is time consuming. So the process of doing inspection for quality, for counterfeit, etc., is a time consuming process. And it also, you at times you need to take samples of the produce itself, which can lead to destruction of them during that testing itself, because it would be typically going into a lab and being tested with some other some other material or some other ways. Maybe it is some X-ray or heating or just putting some chemical on it to test it. So what lot of work which we do, especially like in paintings, we are trying to eliminate that by just using other kind of multispectral imaging techniques y- to capture the images, on which we can use AI to actually understand the painting, the actual, you can say, the whole, uh, you can say, chronology of that painting, and what is the pigments used, and what was the strokes of the painter, which is belonging to the original versus what could be a potential fake. The other one is, this may not be a technology which is eliminating, but definitely it can give us a better confidence level in any of the use cases that we apply. And then as our confidence in the solution improves, there are chances we may be able to achieve automation in that whole, you can say, pipeline. The other one is it gives us results in real time. So at times what happens is, we had this example where there is oil which is getting reused again and again in, let's say, restaurants, and there are food inspectors like in Europe who regularly visit these restaurants to see whether the oil which is being reused for frying is that fit for use or not. And what they typically would do is take a sample and send it to a lab and wait for 3 days to get a assessment. Whereas if you have a technology which can work, as you saw in the video as well, on liquid substances, using an apparatus which is here, you could actually eliminate and make again this process real time. And these are some of the experiments that we have actually done. Second thing is, any kind of such technology involves a lot of domain knowledge and expertise, which again, you are dependent on talent. And finally, at times, not being able to assess quality. The quality inspection in typically manufacturing of produced products remains to be a manual step, because again it requires the human expertise, the sense, the all the senses of the human are involved in assessing the quality of the produce, right? And at times, that is a very time consuming process, and again it is subjective. So there is a potential to automate entire quality inspection pipelines by enabling this technology and making it real. And as I said, again, it is low cost, and it is, you can say, growing in terms of, if you look at the proof of technology points, you'll realize that this technology can be developed quite easily compared to, the investment which may be required in a lot of other, uh, you can say, solutions around the AI space, something like, let's say, autonomous driving. Compared to that, this is a much more specialized niche and technology which can be easy for users to adopt, given the fact that it is something which is edge ready. It is on your mobile, you can use it anytime. And secondly, also because it is easy to, comparatively easy to, you can say, deploy. Some proof of technology points which I like to share, which we've done as part of, our work with IBM's clients, is, one is the painting. So we have an apparatus like this in which our optical instrument on the phone is actually mounted on a surface on which we have a painting, and we take some typical important regions of that painting to kind of detect and create our training data to train on. And we try to enable first to learn the patterns in of the painting in the original, and then typically our clients would be somebody who's dealing in art forgery, so they would also be able to provide us with good description and samples of what a typical forgery would look like. Using that, we would simulate images, or we would typically either image the counterfeit as well as create some simulated images to develop algorithms which can detect the counterfeit. And at times we use multispectral imaging for these kind of activities, and the results have been pretty impressive, as you can see in this proof point. In another example, we actually worked with liquids. So there was this vodka sample, and we had to detect counterfeit vodka instead of a typical brand of vodka, which is quite expensive. And what you will see here is, it's quite a complex problem, because vodka is a colorless liquid. So when you when you are actually looking at the material visually, if you just look at it from the picture, it will appear like a gray image. So for doing that, we do have to use a lot of advanced image processing techniques to see what kind of color spaces to use, and how can we get a signature of the original which may be different than competitor brands, or even non-conformant liquids which could be like tap water with some alcohol mixed in it. And how do we develop a signature for the product so that it can be, identified as counterfeit or original, or maybe a competitor product getting served instead. So you could actually think of, taking your mobile phone out and going for a drink and being very sure that what you're buying is worth what you're paying for. So these are two interesting proof points. We are also working with a lot of retailers, as I said, in detecting products for the counterfeit. Then we have use cases in almost all areas of like different industries. And the way we deliver these solutions is we get into partnership for co-creation with clients, and that's important both because this work involves considerable R&D to to develop a technology or a solution which will suit that particular substance, and or produce like a currency note or a painting, etc. And the other reason is also the domain expertise is always in hands of the people who are involved in that business, right? So you need to definitely bring that domain expertise in and leverage that in doing your solution design. The second thing is the risk of technology failure is high. There is everything will not always be simple to solve. So the way we plan our delivery is we always try to do an initial proof of technology in which we identify a use case, a substance, and we try to make sure we are able to prove that the technology can be developed before we go on to other phases. And uh, and a lot of design thinking goes into see how will we actually present that solution back to the client, right? What kind of navigation on the application would be needed to make it easy and usable. So because of all of this, we always have a kind of phased approach where we de-risk the project and co-create with our clients to enable the technology to come to life. So with that, what I thought it may make sense in today's discussion with the audiences to just share my thoughts about why this technology is still full of challenges and at the same time full of opportunities for innovation. And everybody, whether you talk about school students, engineers, researchers, big companies, startups, can all collaborate or work individually to make such kind of technology more accessible to everybody. And it's pretty easy. So, some of the areas where the challenges do exist is that while the technology itself is easy, at times training data can be difficult to gather. And that's why the partnership is needed with a company which will have this data and will have the domain expertise to help us understand the use cases. And the other thing is, unlike a lot of other AI solutions, there is not enough data because you'll have always have less counterfeit products or low quality samples to go in. Secondly, you can't even define in the real world, you can't define what a counterfeit or a forged product will actually be like, because you will never have it with you in the first place. So this entire solution goes into the realm of unsupervised learning, where we don't have annotated data, where we need to understand what is the digital fingerprint of the substance and then compare it to the rest of the world, right? And because of that, there is a lot of reliance on unsupervised training patterns, which is an open research area. We use a lot of advanced imaging processing. We are not yet like also video, right? We work a lot with video, but beyond that, it is not like uh, there is so much room for research and improvement in different industries to get this technology more mature. And it really involves about being able to identify diverse patterns in different sensory data. So we'll talk about what all sensory data may, in addition, help this whole technology be more strong. The other challenge which we have is we need to develop the technology which is very robust. And when it is robust, we need to make sure it is time and data shift invariant, The technology itself is generalized. So, for example, in the vodka example which I just showed, there was a condition which we had to keep during the POC, that there will be a certain temperature at which the liquid will be imaged, because it is the reflectance from the liquid which is helping us be more informed about it. Now that is a like restriction, because in the real world when you deploy the solution, you may have to provide a range in which that whole technology works. So for that we have to really be very careful in identifying what are the ambient conditions and make sure they're as real as they would be in the practical world. So this will enable us to maintain performance in real time and in the production settings. The second thing is to make sure that there is trust in the prediction which is there, and to validate the prediction we need to make sure that whatever samples we test on, they actually belong to the same kind of data on which the whole model was developed. So that there we need very strong frameworks for out of distribution detection. And what we have seen is a lot of the existing open source frameworks around for out of distribution detection don't work. So this is another area of research where we continually are working to see how do we make our detection frameworks more stronger. And of course there is limited ability to train on the device, so there is a lot of incentive to improve compute and achieve more scalable edge device computing, so that we could enable some kind of training or continual learning on the device itself. Another important aspects with our clients is that for the industry to really trust the kind of solutions that get developed in this space, you need to make sure you can you can have a good interpretation from the model, so that as a AI expert, you are also convinced that yes, this model has learned the right patterns which were hidden uh, in the samples, and therefore it is learning the right signals which will help us in doing the right predictions. So establishing, and especially with vision and different sensory data, establishing this interpretability of the model, this is also a very is an open and very high priority research area for us. So uh, apart from all this is really related to the modeling, but just the advancements in sensor technology, AI processes capability, model compression techniques, UX design becomes a very integral part of what all can be done in this space to just grow this whole, you can say, capability in a better manner. And that will enable us to really bring the verify solutions into the real world. So what the future really beholds for us, I'll just like to end with that. So the sensor technology is getting smarter and of course mobile ready. I showed you the example. We are very strongly, kind of IBM research has done a lot of work around the vision, whether it is multispectral, microscopic, high resolution, thermal, IR, near IR. So we have microscopic lens which works on bacteria detection in, let's say, food manufacturing. Let's say there's a meat plant which is manufacturing food. On the conveyor belt, we are using this technology to see whether there will be a presence of bacteria in the meat which is getting manufactured, and can we just eliminate any kind of presence of that, or at least alert the operators on the floor if such an event happens. So this is, and it's same is for the different kind of produce, like the advancement in video technology with our PTZ cameras, which can zoom and have very special features. Again, the more powerful cameras for video on smartphones. When we talk about audio, all use cases are not something which will be based on vision only. Many times, the domain experts would use multiple sensors, like, for example, smell. For the smell of a shoe can help us in actually detecting whether a shoe is, authentic, having the leather which the original manufacturer is using, or is it a kind of fake. So they use smell. Similarly, for a lot of drinks and food produce, a lot of fragrances, the smell is a big indicator. And today we have technology where we have digital olfaction available with some companies which work with biosensors to give us a digital sense of the smell, which can be used as a sensory input into this entire technology. So, and again, we have sound intensity detectors already available. So at times, what we are also trying to see is how do we integrate all the sensory data within a single application to enable, better sensors to help us identify a better, verify the substances better. The other area is, of course, mobile computers improving. The mobile penetration itself is growing, right? So smartphones are becoming ubiquitous, and therefore, and people also expect that a lot of the solutions should be mobile ready for them to be used. If you talk about a more factory setting or industrialized setting, the 5G can enable last mile connectivity so that if required, we don't have to always deploy our models, especially if you have a multi-model quality inspection pipeline, then maybe mobile is not the solution. You would need to have some kind of a edge compute, at least at the factory shop floor, which can help you through the entire quality inspection process. So technologies such as 5G, etc., make our IoT connectivity to the edge compute more, you can say, powerful. And of course, then the unsupervised machine learning advancements are happening every day with the research in the field. So that also helps us inform it. As open source and standardization in the frameworks comes, this is becoming more and more of a do-it-yourself technology. So anything that I described is, if we have the right use case and the right organizations who can partner with us in co-creation of these solutions, anybody can actually use this technology today, both from a cost standpoint as well as from the capabilities of accessible technology, the open source frameworks being available. It can really help us develop a healthy ecosystem around such solutions, which can be, again, kind of uh, created in a services oriented manner, where at the end you could have, let's say, some open source services or APIs which are solving for some common substances authentication automatically. So that is what the future holds. And then, of course, all we need is really a will to be ready for experimentation, and to really get this technology in the hands of the people who can use it readily. So with this, I'll wait if there are any questions or any other details needed. Then I'm happy to answer any kind of questions.
Trapti, thanks so much. We're running short of time, but we definitely want to ask you one question, which is what you did take us through what the future holds. But as always, whether we speak about the intersection of AI with anything, including edge computing, are there any ethical considerations that you would sort of look at and caution us about?
So yes, so one thing which I did talk about is from an ethical standpoint is the fact that we are enabling this technology to be localized. That's what why we talked about edge in particular, is we understand that the data on which we are acting is would be typically part of an industry or a company or a person who's anyway providing a very niche service. So in that sense, providing for a solution which can be very very focused on the needs of that particular customer, that is how we make sure that there is ethical consideration is definitely maintained there.
Yeah, I mean, this is a huge topic. Your entire presentation, I think the kind of takeaways for us here at Boom, but also the people here who are watching and the attendees of this conference, there are multiple reference points and opportunities to delve deeper into this topic. And we'll have to leave it at that, though. However, thank you so much, Trapti. I mean, this, along with all the other panels, they've been mind opening. And especially with the intersection with edge computing, because this is not something we tackled earlier. So thank you so
Yeah.
much.
Thank you.